Welcome to BGP series. Guys, topic for the day is indirect neighborship in BGP. Indirect neighborship in BGP. BGP. So first we will discuss indirect neighborship in Ibgp and then we will discuss indirect neighborship in Ebgp. Right? Okay. So first of all, I am going to show you how to form Ibgp neighborship between two router. Right? Suppose we have two loopback. One loopback is 1.1.1 over here and one loopback is 2.2.2.2 over here. Right? First of all, we will discuss how to form neighborship between 1.1.1 and 2.2.2.2. Right? Here I am using BGP 100. Yes, 100 over here. Right? I am going to configure IP 12.1 over here and 12.2 over here. Fine. So we will discuss each and everything step by step. Don't worry. First we will configure between two routers. Then I will add one more router over here, R3 as well. Right? But guys, first of all, understand why I am using loopback to form neighborship, indirect neighborship. Actually, company is recommending whenever you are going to form Ebgp neighborship, your Ibgp neighborship, but neighborship is indirect. Always use loopback address. Why? Understand the logic behind it first. Suppose this is my R1, R2, R3 and R4. We have four router. Okay. And suppose I want to form neighborship between R1 and R3, right? R1 and R3. So if I will use exit interface IP address, yes, this interface IP address, physical interface IP address 12.1 and 23.4. Suppose the IP address of this interface is 23.4. So if I will use this IP address, right, to form neighborship between R1 and R3, right? Then guys, what the problem is there, understand, for connectivity between these router I am using, suppose any IGP protocol just like EIGRP, suppose I am using EIGRP over here. So if I will use this IP address and this IP address to form neighborship between this R1 and R3, if this router will goes down, my BGP neighborship will down, right? And EIGRP will again calculate path to reach R3 via R4, right? But my neighborship will not change. My neighborship will down. And if I will use loopback over here, right? 1.1.1 and 3.3.3.3. If this router will goes down or this link will goes down, where EIGRP will elect this path to reach in R3, right? My BGP neighbor will still up there, right? Because I am using loopback IP address. So that's the reason why company is recommending always use loopback address while you are forming indirect neighborship, right? So guys, without wasting our time, let's discuss in GNS3. Let's discuss in GNS3. So you can see over here, I have one topology, right? We have two router, router 1 and router 2. First of all, let me configure IP address. After that, I will configure BGP 100 over here and 100 over here. After that, I will form neighborship between 1.1.1 and 2.2.2, right? We are going to discuss each and everything step by step. Don't worry. If you feel any doubt, you can let me know in comment, right? Don't worry about that. You will be understand each and everything after this video, right? Please watch this video till the end, guys. Otherwise, definitely you will feel some doubt. So interface serial 2/0, no shutdown, IP address 12.1.1.1, 255.255.255.0. Exit interface loopback 1, IP address 1.1.1.1, 255.255.255.255. IP configuration is done. Let me configure IP on R2, right? Interface serial 2/0, no shutdown, and IP address 12.1.1.2, 255.255.255.0. Exit interface loopback 1, IP address 2.2.2.2, 255.255.255.0. Right? Now for connectivity between R1 and R2, I am using static routing over here, right? You can use any IGP protocol as well or static routing as well. But remember, you can't use default route, right? If I will provide default route on R1 towards R2 and I will configure default route on R2 towards R1, then indirect neighborship will not form, right? Either you can use a static routing or IGP protocol. So always keep in mind this point, right? Now IP route, let me configure a static route for 1.1.1 network, subnet mask 255.255.255.255 and exit interface will be serial 2/0. Let me configure static routing on R1. So route IP route 2.2.2.2 and serial 2/0. Serial 2/0 and subnet mask is 255.255.255.255, right? Let me ping 2.2.2.2 and source 1.1.1.1. Now I have connectivity between 1.1.1 and 2.2.2, right? Now let me configure BGP over here. So router BGP 100 and neighbor is 1.1.1.1 and remote AS is 100. Fine. Can't configure the local system AS. Neighbor 1.1.1 remote AS is fine. So let me check the neighbor table. So IP BGP summary. So IP BGP summary, no. Router BGP 100 neighbor 2.2.2.2. Sorry, I was configuring neighbor 1.1.1.1, right? So 2.2.2 and remote AS is 100, right? So let me configure BGP on R2. So router BGP 100 and neighbor 1.1.1.1 and remote AS is 100, right? Let me show you the neighbor table. So IP BGP summary. As you can say, neighbor is down. Neighbor is down. Actually, why neighbor is down? Understand, when this router will send open message, this router when R1 will send open message will generated at application layer. Open message. After that, application layer will hand over to transport layer and transport layer add one random port number 1025 suppose and destination port number will be 179. After that, transport layer will hand over to network layer and network layer will add source IP, destination IP. So source IP will be 12.1.1.1 and destination IP will be 2.2.2.2. When this router will receive this update, right, this open message, this router will check source IP from where this message is coming from 12.1.1.1.1. But 12.1.1.1 is not my neighbor. Who is my neighbor? 1.1.1.1. So you have to modify source IP address over here, right? You have to modify source IP address. How you can modify source IP address? Go to R1. And let me tell to R1 that whenever you will send open message or any message of BGP, always set source IP 1.1.1.1. So my neighbor is 2.2.2.2. Update source loopback 1. Right? You need to run this command. Right? After that, R1 will send message where source IP will be 2.1.1.1.1. Right? And let me run the same command on R2. Right? Let me run same command on R2 as well. Router BGP 100 and neighbor 1.1.1.1. Update source loopback 1. Now this router will send open message where source IP will be 2.2.2.2. Whatever IP address we are running on loopback 1. Whatever IP address we are running on loopback 1, that will become source IP for open message or for any BGP message. Fine. So IP BGP summary. You can see over here now neighbor is up, right? Now neighbor is up. So this is how you can configure indirect neighborship in Ibgp. Let me change the AS number over here. Let me configure AS 200 over here, right? After that, I will show you how we will form neighborship between 1.1.1 and 2.2.2. So first of all, let me remove 100 BGP 100 over here. Configure terminal. No router BGP 100. Fine. Neighborship is break. Right. Now let me configure router BGP 200. Right. After that, neighbor 1.1.1.1 and remote AS is 100, right? And let me remove router BGP 100 and neighbor 2.2.2.2 and remote AS is 100. Let me put no command, no over here, right? No, exit. After that, sorry, router BGP 100 and neighbor 2.2.2.2 and remote AS is 200, right? Now let me show you the neighbor table. So IP BGP summary, right? You can see neighbor is down. Neighbor is down, right? Why? What's the problem now? Now this order is sending update in open message. What will be the source IP? Source IP will be 12.1.1.1. So let me modify the source IP address. So router BGP 100 and neighbor 2.2.2.2 update source loopback 1. Right? Let me run the same command on R2. Neighbor 1.1.1.1 update source loopback 1. Whatever IP address I am configured on loopback 1, that will set as a source IP address. Now let me show you the neighbor table. So IP BGP summary. Still neighbor is down. So guys, now here is one concept, and that concept is this. That concept is, if anyone know, right, please let me know in comment. Please write in comment why this neighborship between 1.1.1 and 2.2.2 is not formed, right? Please let me know if anyone know the answer. There is concept of connected check, disable connected check rule. Disable, there is one rule guys, disable connected check rule, right? Disable connected check rule. So actually by default this rule is enabled on router. That means whenever you are going to configure indirect neighborship in Ebgp, that router, your neighbor, must be directly connected to your router, right? So 2.2.2 is not directly connected to 1.1.1, right, or R1. So that's the reason why neighborship is not forming between 1.1.1 and 2.2.2. So let me disable this rule, right? Let me disable this rule. Rule is connected check rule, right? Now R1 is checking that 2.2.2 is connected to me or not. So 2.2.2 is not connected. That's why neighborship is not forming, right? So let me disable this rule. This rule is enabled by default, right, on router. So how can we disable neighbor 2.2.2.2, neighbor 2.2.2, and after that disable connected check, right? Now this router will not check, right? Now this router will not check my 2.2.2 is directly connected or not. Let me enter this command and let me run same command on R2 as well. So router BGP 200 and neighbor 1.1.1.1, right? After that disable connected check rule. Now let me show you the BGP table. So IP BGP summary. Now you can say neighbor is up, right? Now neighbor is up, right? So this is how you can form neighborship in eBGP, indirect neighborship in eBGP, indirect neighborship in BGP. Don't worry, we will discuss where we should configure, where we need to configure eBGP neighborship or IBGP, indirect eBGP neighborship or indirect IBGP neighborship, right? We will discuss this thing in next video. Don't worry about that. But understand one more concept over here, right? Guys, in eBGP, whenever router will send any BGP message to eBGP neighbor, it will send TTL 1. It will send TTL 1. Now there is only two routers, so there is no problem. But suppose if we have one more router over here, R3, and here is one loopback 3.3.3.3, and I want to form neighborship between 1.1.1 and 3.3.3, then how I will form neighborship? Because this router will send TTL 1. So let me show you in Wireshark. Let me capture the link first. Let me capture the link. So in IBGP, router will set TTL 255, right? No problem there. But in eBGP, router will set TTL 1, right? So my packet is capturing or not? No. Where is Wireshark? Stop capturing and let me start capturing again. See the BGP message. Let me shut down this interface serial 2/0 shutdown and no shutdown, right? Let me show you in Wireshark. R1 will send keep alive message, right? Who is sending 2.2.2 to 1.1.1? Let me open this message and let me show you the TTL value. In IP adder, you can see the TTL value. TTL value is 1, right? TTL value is 1. But when you will configure IBGP, you will see TTL value will be 2, right? So we will discuss how to modify TTL value as well, right? So first of all, let me take one more router over here. Right? Let me remove this loopback from here. Let me connect this router to R3. Okay, guys. BGP 200 over here. Let me stop the Wireshark. Let me turn on this device. Okay. Fine. Let me remove BGP over here. Let me remove BGP over here. No router. BGP 200. Right? Interface loopback 1. No IP address. Right? No IP root 1.1.1.1 255.255.255.255 and serial 2/0. Let me remove static routing from here as well. Exit. No IP root 2.2.2.2 255.255.255.255 and serial 2/0, right? Exit. So IP root. So there is no any entry for 2 network, right? So here I am running BGP 100, right? And here I will run BGP BGP 200 or 100. First I will run BGP 100, BGP 100, and for connectivity, now this time I will configure Ibgp protocol. I will run EIGRP, or you can run any IGP protocol for connectivity, no problem at all. So let me configure the IP address on serial 2/1 interface, serial 2/1, no shutdown, IP address 23.1.1.255.255.255.0. So I am configuring 23.2 over here, and I will configure 23.2 over here, right over here. So configure terminal interface serial 2/0, no shutdown, IP address 23.1.1.3 255.255.255.0. It. Now let me create one loopback over here. Loopback 1 IP address 3.3.3.3 255.255.255.255. Right. Now let me configure EIGRP for connectivity. So router EIGRP and network 0.0.0. Okay. Now let me configure EIGRP over here as well. Router EIGRP 100 and network 0.0.0. Let me configure EIGRP over here as well. Configure router EIGRP 100. Actually, on R3 S number was 10. On R2 S number was 100. So let me remove no router EIGRP 100, router EIGRP 10, network 0.0.0. Fine. Let me configure EIGRP on R1. So network 0.0.0. Let me ping 3.3.3.3 and source 1.1.1.1. Yes, connectivity. There is connectivity between 1.1.1 and 3.3.3. Where is 3.3.3? 3.3.3.3. Fine. Let me configure indirect neighborship in Ibgp, right? Because I am using 100 S over here and 100 S over here, right? Guys, in next video tomorrow you will understand where you need to configure indirect neighborship, right? So router BGP 100 neighbor 3.3.3.3, neighbor 3.3.3, right? Let me check the neighbor of BGP neighbor first. So IP BGP summary. So there is one neighbor, right? 2.2. But this neighbor is down. This neighbor is not down. Actually, I have to remove BGP from here and BGP from here. So IP BGP summary. So there is no neighbor, right? So let me remove BGP router BGP 100. No. Let me configure BGP again. BGP router BGP 100 and neighbor 3.3.3.3 and remote AS is again 100, right? Let me configure BGP over here. Router BGP 100 and neighbor 1.1.1.1 and remote AS is 100, right? Let me show you the BGP table. So IP BGP summary, right? Neighbor is down. Why? Because of remember, because of source IP address, right? So let me configure, let me modify source IP. So router BGP 100 neighbor is 1.1.1.1 and update source address loopback 1. Let me run same command on R1. Neighbor 3.3.3.3 update source loopback 1. Right? Now let me show you the neighbor table of this order. So IP BGP summary. You can see neighbor is up now. Right? So this is how you can form neighborship, indirect neighborship in Ebgp. Let me configure 200 over here, and now there will be problem of TTL. So we need to modify TTL now. Right? So let me remove 100 BGP 100 over here. No router BGP 100, right? No router BGP 200, right? And neighbor 1.1.1.1. Neighbor is 1.1.1.1 and remote AS is 100, right? Let me remove IBGP neighborship from here as well. So router BGP 100, no neighbor 3.3.3.3 and remote AS is 100, right? After that neighbor 3.3.3.3 and remote AS is 200, right guys? After that router BGP 100, and let me show you one thing. So IP BGP summary. So neighbor is down. Router BGP 100 and neighbor 3.3.3.3 update source loopback 1, right? Let me run the same command on R3. Neighbor 1.1.1.1 update source IP loopback 1, right? Let me show you the neighbor table. So IP BGP summary. Again neighbor is down because TTL, what TTL value R1 is including in open message 1, right? And when this router R2 will receive, right? When actually now this router is sending open message where source IP is 1.1.1.1, destination IP is 3.3.3.3, right? And TTL is 1, right? When this router will receive this at this update, this open message at this interface, now this router will check destination IP is 3.3.3. To forward traffic to 3.3.3, this router will check their routing table, right? So IP route. So there is one network for 3.3.3 which is connected on which interface, right? Exit interface is serial 2/1, but 3.3.3 is not connected to my interface, right? And TTL is 1. So if this router will forward this update, to R3, TTL will become 0, right? TTL will become 0. So this router is dropping this update message on R2, right? Because when TTL value will 1, right, that router will never pass that traffic, right? So now we need to modify TTL value, right? Guys, if anyone know how to modify TTL, please write in comment. If you don't know, don't worry. Let's see. Go on R1. Go to R1. After that, neighbor 1.1.1.1, right? And Ebgp multihop. Now, what TTL value we required, right? 2. So let me put 2. If I will set TTL value 2, then there will be any problem? No. If there will be one more router between 1.1.1 and 3.3.3, then we have to set TTL value 3, right? Now I am going to set TTL value 2, right? Can't configure the label system as neighbor. Okay, so neighbor is not 1.1.1. I am on R1. Neighbor is 3.3.3.3. Enter, right? And the same command we need to configure on R3 as well. Configure router BGP 200 and neighbor is 1.1.1.1. Neighbor is 1.1.1.1. After that, Ebgp multi-hop set TTL as 2. Now let me show you. So IP BGP summary. Now you can see neighbor is up from 5 seconds. Neighbor is up from 5 seconds. So guys, this is how you can for indirect neighborship in Ebgp and Ibgp. If I will capture this link, let me capture